no need for you to actually reverse. You would take your electrode potentials as they are. Our reduction reaction itself, this one is plus 0.4, and then we are going to subtract the electrode potential of our oxidation reaction, and our oxidation reaction is electrode potential of minus 0.44. So we're going to get also the same answer, which is 0.84. So because our electrode potential is positive, the reaction is actually spontaneous. Let's continue with our next question, which is question 1.2, which is saying magnesium is used to protect underground iron pipes against rusting. The diagram which you see here shows an iron pipe connected to a magnesium bar, right? So now the first question, which is question 1.21, says use the table of standard reduction potentials to explain why magnesium can be used to protect an iron pipe against rusting. So remember what we have already said. We have said that in this particular question, there is need for us to actually use our standard reduction potentials. If we are going to take the standard reduction potentials for the two reactions, we see to it that our magnesium 2 plus 2 electrons will give us magnesium, and then the electrode potential for this one involves is minus 2,37, right? That one for ion 2 plus 2 electrons will give us ion there, right? Minus 0.44. So we have minus 0.44 volts. So as we can see, these two particular reactions, both of them, they are involved in reduction reactions. Why? Because we're adding electrons there. But from the look of things, that one for magnesium is more negative than that one for iron, which means to say that this particular reaction is unlikely. Magnesium actually loses electrons readily than iron. So we see to that we're going to actually reverse our half reaction, and we are going to have our magnesium 2 plus 2 electrons, and so the electrode potential for this one now is plus 2,37 volts, right? If we are going to look closely on this particular reaction, we see to it that our ion reaction, that one for ion, we see to it that our ion 2 plus 2 electrons is supposed to give us our ion there, right? And this one remains a reduction reaction, right? So the first question which is there is saying that use the table of standard reduction potentials to explain why magnesium can be used to protect an iron pipe against the reduction, right? So our ion there, for it to be actually oxidized, right? For it to actually have some rust, there is need for that particular reaction to be an oxidation reaction. But as you can see, our magnesium actually performs a reduction, an oxidation reaction more readily than iron. So in this case, our iron is going to be protected by magnesium. Why? Because our magnesium is going to be oxidized first before the iron. So that one will be our answer, right? Or we can actually say that iron itself is a weaker reducing agent than magnesium and will not be oxidized, right? Or we can also say that our iron will not lose its electron easily compared to magnesium and will not be oxidized. So our magnesium itself is a stronger reducing agent than iron and will be oxidized and not iron. So we are going to prevent our iron pipe from being oxidized. If we go to question 1.22, it says the iron pipe in contact with the magnesium bar forms an electrochemical cell, right? What cells at the salt bridge for this cell, right? Remember, I gave you the three functions of the salt bridge. I said the first one, our salt bridge acts as an ion exchanger, and secondly, I said our salt bridge actually completes the circuits, and thirdly, I said that our salt bridge actually separates the two electrolytes. So now we are having some electrolytes in this particular soil, or some salts which are dissolved in the moist soil. Therefore, those ones are going to act as our salt bridge. So our electrolytes which we have in the soil, or the salts which are dissolved in the moist soil, are the ones which are acting as our salt bridge. Then question 1.23 says, give a reason why the magnesium bar must be replaced after some time. Remember, we have said that in this particular reaction, our magnesium being converted to magnesium 2+, this one is an oxidation reaction, which means to say that our magnesium is the one which is acting, our magnesium bar is the one which is acting as the anode, right? And at the end of the day, we see to it that our magnesium is being oxidized to magnesium 2+. So as a result, we see to it that our magnesium becomes corroded, or it is going to be used up. So there is need for it to be replaced time to time. Why? Because it is actually being oxidized here, as you can see, right? So question 1.25 is saying, name two other methods that can be used to protect iron pipes against rusting. So we have number one, you can paint your iron pipes. So painting can actually excludes one, the moisture as well as the oxygen. So that one can help. Then we have what you call electroplating. That is when we are coating our iron pipes with another metal, which is the one which is going to be oxidized. And at the end of the day, we can also prevent rusting. We can also oil, or we are going to have what we call waterproofing. Oiling itself will actually avoid the moisture to enter into our iron pipe, as well as our waterproofing. So it will actually exclude the conditions which are necessary for the process of rusting. Then we also have what you call galvanizing, and we have plastic coating. All these ones, they actually exclude oxygen and moisture which are necessary for the process of rusting. Then question 1.26 says, state one advantage and one disadvantage of using plastic pipes instead of iron pipes. So the advantages which we have is that the first one, the plastic is cheaper, and secondly, our plastic does not rust. The disadvantages now Our plastic itself is not degradable, which means to say that it is not environmental friendly, and as a result it can cause pollution, right? And our plastic again is not as strong as iron. That's why we normally want to use the iron pipes, right? So let us just go and drink a glass of water, and then stay tuned for the second question, which is question 2, so that we can actually proceed with our examination type questions well.